Hi there, this is Professor Eckhouse, and I'm going to talk today about writing ratios and calculating rates. And these are all the things we're going to talk about if you want to pause the video and look. But I'm going to move on. So we're going to start by writing a ratio as a fraction. And this is something we've been doing. But a ratio compares two numbers that are measured with the same unit. That is really key, the same unit. So the ratio of A to B, as written as A over B or A to B like that, but we're going to use the fraction. Okay, so today that's what we're focused on. So ratios involving integers. So write each ratio as a fraction, pause the video and try these two, and then you want to be sure to reduce it, and we're not going to do decimals, we're just writing it as a fraction. Okay, so the way you're going to write this as a fraction is 12 to 18, and then that reduces by saying how many 6's go into 12, 2. How many 6's go into 18? 3. So we get 2/3. All right, the next one is 35 to 15, like that. And you're going to look for a common denominator, a common factor. And you'll see that they both have a 5 in them, so 7 times. How many times does 5 go in? How many times does 5 go into 15? 3 times. So this becomes 7/3. And you can leave it like that because we're just looking at ratios, so we don't use mixed numbers at all. Okay, so what if you're given a ratio that has decimals in it? We never have decimals in fractions. I'm going to highlight that. We never have decimals in fractions. So what can you do with this ratio? So what you want to do is you want to look for the one that goes to the farthest to the right of the decimal place and think about what place value does that go to, and what would I have to multiply it by? Well, we looked at how multiplying something times 100, so say 100 times 1.3 is going to move the decimal place 2 places over, and we get 130, right? So we need 100 to be multiplied on the top. Well, whatever we do to the top, we need to do to the bottom. So we would multiply top and bottom times 100. And when you multiply 0.06 times 100, you get 100 times 0.06 is going to take the decimal point, and it's going to move it over 1, 2 places to the right, and you get 6. Okay, so the top becomes 6. The bottom is 100 times 0.5. It's going to move the decimal place over 2 places to the right, 1, 2, and put it there, which means we have to put a 0 in, and it becomes 50. Okay, so 50, 6 over 50. So 0.06 over 0.5 is 6 over 50, which then reduces, because we can look at it and say how many 2's are in 6. We have 3. How many 2's are in 50? 25. So this becomes 3/25. Okay, don't even look anything alike, do they? So that's how you do that. All right, so you give this a try by pausing the video and see what you can do with it. Okay, so 3.2 to 10.2. Both of those go to the tenths. So if I multiply it by 10 over 10, I'll get whole numbers. So that becomes 32 on top, and the bottom becomes 102. All right, now those are both divisible by 2. So I'm going to say how many times does 2 go into 32 is 16, and into 102 is 51. And you should get 16 over 51. All right, the next one is 1.9 to 3.8. So again, if I multiply both of them by 10, I'll get 19 over 38. All right, well, I know that 19 goes into 38, so how many times does 19 go into itself? 1 time, and into 38 2 times, and so this becomes 1/2. And you could do that directly from there if you recognize that it's 1/2. All right, moving on. So ratios involving mixed numbers, we are not going to cover this, and it will not be in any practices or homeworks or exams or anything. Not be in the knowledge check, nothing. See the text if you want to learn it. All right, so writing a rate as a fraction. So some examples of rates in everyday life. So one thing is speed. right? Miles per hour, kilometers per second, meters per second, whatever it is, velocity, however you want to think of speed, velocity. Cost of items. So you can say it costs $10 per, whatever you're talking about, and that is a rate in everyday life. Something else that we do a lot is talk about the mileage, miles per gallon, miles per gallon. So if the word per is there, that is one word that is definitely going to tell you you're indicating a rate. So what are some other words we may see that indicate a rate? Well, you might see something like in. There are 24 cans in a case, right? 24 cans per case or something like that. So you might say in, you might see for every, and you might even see the word rate. Okay, so a rate compares two quantities of different units. So I want to contrast this with ratio. Ratio has the same units, and a rate has different units. And it's usually written as a fraction with the rates often. So we want to leave the rates, leave the units. I even wrote it wrong. Leave the units. So leave those units there and write it on the top and the bottom. All right, so when writing a fraction as a rate, first we basically put the first given amount with its units in the numerator and the second given amount with its units in the denominator if the word per is there. So the thing said first goes on top. It's pretty straightforward. So some friends are on a road trip and drove 840 miles in 15 hours. So 840 miles in 15 hours. You could also say per, 840 miles per 15 hours. Okay, so that's our fraction. Now, we found that the friends were driving at a rate of 840 miles in 15 hours. Is this useful as a speed? Is that a speed that you would have on your speedometer? No, your speedometer in the US is miles per hour, right? Which is what we have right here, but it's per 1 hour. Miles per hour. We only have a 1 on the bottom. So what we want to do with this is we want to reduce it. So you would see 15 actually goes into 840, but you could just take your calculator and say 840 divided by 15, and you're going to get 56 miles per 1 hour. And we don't usually write the 1. I'm just going to go like that, 1 hour. So basically, it's 56 miles per hour. All right, so that's how we would convert that into a unit rate, because the unit rate is when the denominator is 1. Okay, so a unit rate is a rate with a denominator of 1 unit. So notice up here we said when we divided by 15, the bottom became 1. So that's how it works. All right, so some examples of ways to write a unit rate. So we've got 68 miles in 1 hour, or 68 miles over 1 hour, or 68 miles / hour, miles per hour. MPH stands for miles per hour. So there's lots of different ways to say a unit rate like this. All right, so let's look at the next one. 36 miles to 1 gallon, 36 miles over 1 gallon, and so on. Okay, so take a look at those, pause the video if you need to. All right, so Rory was paid $408 last week for working 34 hours. So what is the hourly pay rate? Hourly pay rate. Well, a pay rate is going to be dollars per hour or per day or whatever you're going to get paid. So $408 for working 34 hours. Okay, so when you put that in your calculator, you will find 408 divided by 34 is 12. The top unit is dollars and the bottom unit is hour. You can also say $12 per hour / like that, or you can say the word per. Okay, so $12 per hour. That is the hourly pay rate. So the word rate means per something. All right, Anita drives her car 435 miles using 13.6 gallons of gas. What mileage is her car getting? We're going to round to the nearest whole number. Okay, so mileage, remember, is miles, like we just set up above, per gallon, which is miles per gallon. And the unit then will tell us what goes on top if you get confused. So 435, and these are they're easy to get confused. So think about the unit, and that will tell you exactly what you're supposed to do. 435 miles per 13.6 gallons. So I put that in my calculator and I get 31.98529 and a bunch of stuff, but it's supposed to be to the whole number. All right, so we're just going to go to the whole number, that's 31. So this becomes 32 because the 9 brings it up to a 2. So 32 miles per gallon, or you could say 32 miles per gallon because we use that in the US. MPG means miles per gallon. Okay, so moving on, calculating a unit price. So a unit price is a unit rate that gives the price of one item. So the grocery store charges $5 for a case of 24 bottles. What is the unit price? So your unit price is going to be money per item, right? So that means dollars on the top and items on the bottom. So that's pretty important to remember. So the price of one item or the price per one item. Okay, so price goes on top, $5 per 24 bottles. So use the units, don't leave those out because it's going to be your key to figuring these out. And I get 0.208333, and then it just goes on, 333. And it says rounded to the cent. So where is the cents? Well, remember, this is the dollar, this is the dimes, and this is the pennies, right? So it needs to be rounded to that last one, to the pennies, to the cent. So we're going to say equals 0.21, which is dollars per bottle. Okay, so dollars is on top and bottles is on the bottom. That's our item, 21 cents per bottle. Okay, so moving on. If we're comparing two items, how would we find the better buy? How do we know which one is the better buy? Well, its unit price is going to be less, right? The unit price, the price per item is less. Okay, so that's what we're looking for. Okay, so Paul is shopping for laundry detergent. The grocery store, the liquid detergent is priced $14.99 for 64 loads, and the same brand of powdered detergent is $15.99 for 80 loads. So the liquid detergent is that much, and the powder detergent is another price. All right, so we're going to say liquid is going to be $14.99 per 64 loads. Now don't leave out the units, okay? Make sure you've got those so you put the right thing on top. All right, I divide $14.99 by 64 and I get 0.23422-ish, I rounded the last digit, per load, right? That's going to cost that much per load. Whereas the powder detergent is going to be $15.99 per 80 loads. And for that one I get 0.199875 per load. Okay, so make sure you keep this on the bottom, right? All right, so which one is a better deal? Better buy? That's the question. Which is the better buy? All right, so hopefully you see that the better buy is this one. Better buy. Because it's cheaper. Cheaper per load. All right, let's go ahead and try another one. This time I'd like you to try it yourself. We're going to find the unit price and find the better buy for the different brand storage bags. So we've got brand A and we've got brand B. All right, so brand A is $4.59 for 40, and brand B is $3.99 for 30. All right, so we'll do A. Remember, it's unit price, so you want the dollars on top. $4.59 for 40, and I'm going to say, instead of count, I'm going to say bags. That's what I'm looking at. And I get 0.11475 per bag. And that's dollars per bag. All right? And B is $3.99 per 30 bags. All right, and I put that in the calculator and I get $0.133 per bag. All right, so one of them is 11 cents and the other one is 13 cents. So which one is a better deal per bag? We want the lower one, remember, because we're trying to find a good deal. So this one is the better buy. All right, one last one. And again, why don't you try this one and then and pause the video and then come back and see if you got it right. Okay, so brand C is that much and brand D is that much. So let's start with C. We've got $1.89 for 26 ounces. And I'm going to abbreviate ounces OZ. And we get 0.072692 per ounce of soup is brand C. And brand D is going to be 95 cents for 10.75 ounces. So again, just put that in your calculator. Dollars is going to go on top. And we get 0.088372 per ounce. So that's the dollars per ounce. Which one is a better buy? Hopefully you see that it's this one. This one is a better buy. All right, that is all I have to say about that. Thanks for watching.